we are going to discuss the difference between distance and displacement. The best way to start that is to talk about a typical number line. So I'm standing at the 0 position, and to my right, I have positive numbers, and to my left, I have negative numbers. So based on where I am at any given location and how far I travel will tell us what our distance and displacement are. The best way to explain this information is to fill out a data chart. So our data chart we are going to use for this has 5 different data sets and answers 2 questions. How far have we traveled? So in other words, how far have our feet moved over the course of our 5 data sets? And how far are we from start? So for us at start, we're going to call that 0 meters. So let's get started. For my first data set, I am going to go to the right. I'm going to go 2 meters to the right. On my number line system, I am at +2. How far am my starting position? I am 2 meters to the right. How far have my feet moved? My feet have moved a total of 2 meters. Let's put that in our data table. So in our data table, for our first data set, how far have my feet, how far have I traveled? I have traveled 2 meters. And how far am I from my starting point? Well, I'm 2 meters as well, but in the positive direction. So +2 meters. Let's do data set number 2. So for my second data set, I'm going to go to the left, 3 meters. According to my number line, I am now at -1. Negative, according to a standard number line, means to the left of 0. So how far am I from my starting position? 1 meter to the left, or -1 meters. How far have I traveled though? Well, I went 2 meters that way, and then I went 3 meters this way. So how far have my feet traveled altogether? Let's look at the data table. So for my second data set, since I went 2 and then 3 more, my feet have traveled a total distance of 5 meters. Now, how far am I from the starting point? Well, based on my number line, I was at -1 meters. And so I was 1 meter to the left of 0. Now for the next one. Now I'm going to go 1 more meter to the left. How far have my feet traveled now? Well, I had gone a total of 5 meters. I've gone 1 more, so now that is 6 meters traveled so far. And how far am I from my starting point? Well, 2 meters to the left. So that would be -2 meters. Let's look at the data table. So in my data table, you can see that we have now gone 1 more meter. So this number keeps increasing. How far have my feet traveled? It keeps increasing over time. And how far am I from the starting position? Well, this entirely depends on where I am on that number line. I'm now 2 meters to the left of the starting point, so I'm at -2. Now for the next one. For data set number 4, I'm going to go back to the right now. And how about 3 meters? So let me travel 3 more meters. 1, 2, 3. So if I've gone a total of 6 so far, and now I've gone 3 more, then that means I've gone a total of 9 meters. But how far am I from start? Start's right here. I'm 1 meter to the right, which means a +1 meter. Let's see what the data table says. So in data set 4, you can see that I had to go 3 meters more, which means a total of 9 meters. And then I was 1 meter to the right from the start point. So that means a +1. So now let's do our last one. So for my last data set, I'm going to go back to my starting position. So how far have I traveled total? Well, up to that point, I had gone 9 meters, so now I've gone 1 more. So my feet have traveled a total of 10 meters back and forth. But how far am I from start? Well, I'm there. So I'm 0 meters from start. So what does this data table look like? So in my last data set, number 5 right here, notice how far I traveled continues to increase. But look at how far I am from start. 0 meters. So does that mean I haven't gone anywhere? Yes and no. I started and stopped at the exact same spot, but my feet traveled a total of 10 meters. So I have gone somewhere, but looking strictly from a start and end position, I haven't. So how does this relate to distance and displacement?
Well, what it means is that distance is the how far traveled column that we did. Examples of things that have measured distance would be like an odometer. So every car has an odometer where all it does is it just tells you how many miles that particular vehicle has gone. It doesn't have anything to do with directions. It's just a sheer number, that many kilometers, that many miles, depending on where you are. Or if you happen to have one of those like fitness watches or a fitness app that is on your watch or on your phone, where it does like step counts and things like that, the step count, it doesn't care how, like if you went north, south, east, or west or anything like that. All it cares about is how many steps you actually walked. So this one in the odometer would have a unit of, in the US, miles, and then your pedometer, which is what this is, or your fitness apps, it's in step counts. It's X many number of steps. So notice both of these have nothing to do with direction, which means that distance is a scalar quantity. Well, what about displacement then? Displacement was that other column. Displacement is the how far from start. And so a couple of examples of that. Well, from chemistry, you did a water displacement activity, I'm sure, where you put a certain amount of water, and that's your start, and then you dropped an object in, and you saw how much the water raised, and that was your end. And to figure out the volume of your object, it would be the end minus the start. Well, displacement in physics is exactly the same idea. It's wherever you end compared to wherever you started. Another example would be in a path, like if you were to go and take a walk at one of the parks or at one of the state parks or national parks or something like that, and you were taking a trail map, right? So you would have this crisscross, zigzag type of path, but your displacement is where you started to where you ended. And it would be that straight line from start to end. Now, since this one deals with going back and forth and up and down and zigzags and stuff like that, this one actually does deal with direction. So displacement, because of direction, is a vector quantity. So a great picture that demonstrates the difference between this distance and displacement stuff would be this one. So what you should notice is you have starting point A and you have ending point B. And our distance is this dotted blue path. And so we go up and then down and then back up again. But displacement is just a straight line from start to end. How far are you from your starting point? Let's do an example. So I'm one of those that I don't like trying to make up names in my example problems. So I decided to just put insert name. So for your notes, pick whatever name you want. So I run 2 kilometers east and then 3 kilometers west. And so the question is what would be my distance that I traveled and what would be my displacement? So for distance, all it is how far your feet have gone. Well, how far have your feet gone? Your feet have gone 2 kilometers and then another 3. And so your total distance that you would have traveled, how far did you go, would be 5 kilometers. So for distance, you simply add them together. You don't care anything about direction. So this would be a 5K. A 5K is not a straight line from start to finish point. A 5K, you're going to turn down this road, turn down that road, but your feet have gone a total of 5 kilometers. Well, what about displacement? Easiest way to think of displacement is like I was showing you with the number line idea. So here's our number line. And let's get a new color here. Here's our 0 point, right? So this is our start. And I go 2 kilometers east. So never eat soggy waffles. So I'm gonna go 1, 2, and then I'm gonna go 3 kilometers west. So from this spot, I go 1, 2, 3. So this is my start, and then this is my end. And so the question is what is my displacement? You could write it a couple of ways. Well, each of these little tick marks on my number line is 1 kilometer, right? And so from start to end, it would be 1 kilometer west. On number lines, if you're on the left side, then of course it's going to be negative 1 kilometers. That would also be another way of writing it. And if you don't like the number line idea, you could just say, hey, east is to the right, so that's going to be positive, and west is to the left, relatively speaking, on a map, and so that's going to be negative. And you could just add those numbers together, right? So let's use a different color. So positive, negative. And so I could solve it the same way. Plus 2 minus 3 gives us a negative 1 kilometer. And the negative would also indicate west. So let's do another example. I know it helps to do that. So now, same person, whoever it happens to be, is running 1 kilometer east, 3 kilometers west, and then 1 kilometer east again. So this is a 5K, right? So we got 3, we got 1, we got 1. The distance that this person is covering, 1 plus 3 plus 1, is a total of 5 kilometers, a 5K. We don't care about direction. Displacement, though, we do care. So here we go. Here's our number line. Here's our starting spot. And let's see, we're going to go 1 kilometer to the east. Eat waffles. So we're going to go 1 tick mark over here. Start. And then we're going 3 to the west. So that's going to be 1, 2, 3. And then let's see, I go 1 kilometer east again. So that's going back in this direction. So here is my end point. So for this one, I am still 1 kilometer away from my starting point to the west, which again is a negative 1 kilometer. Now, I purposely did this. I did this where you get the exact same distance and exact same displacement, but what you should notice is that the path itself is different. This one, we go east and then west and then east again. In the first example, it was simply east and then west. Only 2 stretches. But notice, same exact answers. Just the math in order to get to the final answer was a little bit different. If you wanted to do it based on that whole positive and negative thing, we could. Let's see, here we go. East is positive, west is negative, and then east is positive again. So we've got +1 minus 3 plus 1, which gives us -1 kilometer. That negative still indicates westward direction.